Hey, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And as the title of the video suggests, today we are going to learn and understand how you can print a binary tree or a binary search tree in a graphically intuitive way on a command prompt. When I say graphically intuitive, it would mean that it would look like a tree onto the command prompt also with the proper spacing and proper tree structure. Now before we proceed, in case if you've missed any of the previous tutorials, we've been talking about binary tree and binary search tree. In fact, we also started with the implementation of binary search tree, and we've talked about insertion, we've talked about tree traversal, especially the three different DFS techniques, that is inorder, preorder and postorder. We have seen the pseudocode as well as implemented those different operations on a binary search tree. And this video is like the continuation to all those videos. So in case if you've missed any of those videos, do check it out. If you have already seen those, you're good to go. Even if you have missed any of those, you will understand this tutorial, don't worry. And as I mentioned, our motive today is to print this binary search tree, which you can see over here, onto the command prompt in a graphical way. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Now in our implementation in the previous couple of videos, you've always seen this void print 2D function. And I kept saying that I'll explain to you what happens over here in this function later on. But this video, we are going to take a deep look into this entire function. In fact, this is the topic of today's video. And this function does nothing but, as I mentioned, print the tree in a graphical way onto the command prompt. So showing the command prompt result, this is the tree that I'm talking about. You can see our tree 30, 18, 45, 10 and 25. This is a binary search tree, which is nothing but a type of binary tree. I'm guessing you guys already know what is the difference between a regular binary tree and a binary search tree. If not, do check out the previous tutorials. But on the command prompt, you can see that this same tree is kind of inverted in anti-clockwise direction in 90° because it gets easier to represent in that way. So 30 over here is the root node. Then we have 18 and 45 as its children. So 18 and 45. Then for 18 we have two more children, that is 10 and 25. So 10 and 25 is over here. And the only reason why we're using this print 2D function is so that it becomes visually more intuitive, more understandable, and you can graphically or properly see the tree data structure. Okay, so that's the only purpose of this function. Okay, so now that the basic idea of this tutorial is clear, let's start off with understanding the pseudocode. Of course, we will dry run this pseudocode onto our example step by step and understand how the recursion works, because we are going to use recursive functions in this tutorial itself. And then we've already implemented this print 2D function in the code in the previous tutorials also. So you have seen this code previously. So then that's covered. So we simply need to understand this pseudocode and then we can easily understand the code. Okay. So with that being said, let's get started. Now on top of this print 2D function, you can see I have mentioned one line which is hash define global space with the value of 5. So this line is nothing but we create a global variable called global space and assign a value 5 to it. I've written it over here also. The reason why I'm using hash define is because we're using C++, right? And in C++ that's how you define global variables. So this is a preprocessor directive. But if you're using any other programming language, of course there would be a concept of global variables in that language as well. And we will need this global space to add those extra spaces onto the command prompt. So on the command prompt, you can see over here we have some spacing, over here we have some spacing, for this we have some spacing, and even the lines are on different lines horizontally. So to create all those visual representations, we are going to use this global space variable. So we are going to add blank spaces, and how many number of spaces we need to add per iteration is going to be defined or is going to be dependent upon this global space variable. Okay, and of course you'll understand that as we proceed. Right now I'm just trying to give you an overview. And now moving on to our function name is void print 2D because it does not return anything. Print 2D is, I've just named it print 2D. You can name it anything you want. It accepts two arguments, a tree node and the space value. So tree node is nothing but this ping structure. The name is n1. It is created at an address of hash 31 in the memory. the left and right elements are nothing but addresses to the child nodes. So you can see hash 16 is nothing but the address where n2 is created, and hash 99 is the address where n3 is created, and the center value or center element is nothing but the actual value inside the node. It is also known as data, or it is also known as key. So this structure must be pretty evident and must be pretty understandable if you followed the previous tutorials. So yeah, this is what we are going to pass as the first argument, as in the address to the first node n1 or n2 or n3 or other nodes in the tree. And then the second parameter is where you are adding the space. So this variable is going to be taking an integer value which we will pass, and again this will be used to create that spacing, to create that tree structure onto the command prompt. Alright, okay. Now inside this function we have 7 steps, and talking about these steps, at the bottom I have the pseudocode for inorder tree traversal. We've already covered that. We have 4 steps. First step is where you check the condition. So this is the exit condition. The second step is recursively traversing the right side. Then you have printing the value, and then you have recursively traversing the right side. So this is left side and not right. Now, similar to these 4 steps, in the print2d function, just observe step 1, step 3, step 6 and step 7. Step 1 is the exit condition. If r equals to null, then return. It is exactly same as the step 1 in print in order. Step 3 is you are recursively traversing r of right, and of course the space variable is extra. So this is a recursive call to print2d itself, but this time we are traversing to the right. In step 2 you can see we are calling print in order recursively, but we are traversing to the left. Step 6 is nothing but we are printing the value along with a escape sequence. So you come on the next line because you want to print that diagrammatic structure. And step 6 for the print2d matches step 3, because over here also we are printing the value. And the last step, step 7, is again recursively traversing the left side. And in last step for in order, we are recursively traversing the right side. So the only difference between print in order and print2d is that in print2d we traverse the right side first, in print in order we traverse the left side first, and all the other steps in this function, that is step number 2, 4 and 5, are all related to the spacing that is required to be created onto the command prompt. Okay, so they are doing nothing but creating these spaces, and of course you'll understand when we dry run this code. But what I wanted to tell you guys is that this print2d function is operating in a reverse in order way. When I say reverse in order, if you simply swap the statement 2 with statement 4, that is if you traverse the right side first and traverse left side later, this print in order becomes print reverse in order. That is, the in order traversal becomes reverse in order traversal, and it is actually a thing. You can Wikipedia it. I did not cover the reverse in order traversal because we only have to swap these two statements and then it becomes reverse in order. Okay, but print2d basically is actually a reverse in order way only, and all the extra statements that are marked in red are nothing but creating those spaces to create a tree looking structure onto the command prompt. So I just wanted to clarify that, and now that this thing is clear, let's start with dry running this print2d function. Okay, so on the bottom what I've drawn is I've drawn a basic structure of a command prompt. So let's assume this is our command prompt. This is first line, second line, third line, fourth line, fifth line, and so on and so forth. Okay, and inside that, this one block, just assume that it is one space. This is second space, this is third space, fourth and fifth. Okay, so these are just individual spaces. Let's assume they are spaces, and I have grouped 5 of them together because our global space value is 5, and we are gonna add spacing in the multiples of 5. So that's why I've added a bold line after the 5 spaces. But just assume that this is your command prompt with these individual blocks as in single spaces. Okay, we're gonna plot our output onto this command prompt so that when we dry run this print2d function, at every step we get the proper output and it looks like a tree, just like on an actual command prompt like this. Okay, alright, so let's do the first print2d call. Of course we will start from the root node. So in the first print2d we will of course pass n1, that is the root node, and the second value let's pass 5. Okay, you can pass any value over here and that would completely impact the spacing itself, nothing else. So let's say we are passing 5. So first time the r value is nothing but n1 and the space is equal to 5. Alright. So first step, if r equals to null, then return. R is pointing currently to n1. So it's not null obviously, so first step will not be executed. When r will become null, at the very first step itself we will return from this function. So we will not execute 2, 3, 4, 5, 6, 7. So this return statement is nothing but it will exit outside this function at this step itself. So this is the exit condition and it will only happen when you find r equals to null. But right now r is equal to n1, which is the root node. So that's why we are not executing step 1. It is a if condition. So now we will proceed to step 2. Now at step 2 we are saying space is equal to space plus global space. So current value of space that we just passed is 5. Correct? Now we are adding global space to it. Now we just defined global space value as 5. Okay, so this is going to be constant, it's not going to change. So 5 plus 5 will give you 10 and you'll store that again into this space variable itself. So now the space variable is modified and it becomes 10. Alright, okay. So far so good, let's move forward. Now when you proceed to step 3, you can see we are giving a recursive call to print2d function. So print2d is calling print2d and now we are saying r of right. R is currently n1, you can see. Who's there to the right of n1? It is hash 99, which is the address of n3. So we are passing n3 and we are passing space. We just modified the space value and it has become 10. So I'm going to pass 10 over here. Okay. Alright. So a second print2d call is made from the first print2d. So it's a recursive call. And when that happens, the first print2d goes into a pause state. So first print2d will be paused at step 3. Because this is where the second print2d is called. So this second print2d is called from first print2d and first print2d goes in a pause state at step 3. And now the execution of this second print2d will start and we've passed n3 and we've passed the space value as 10. Also do note that in the first print2d the space value has become 10. So let's write 10 over here, because it is modified from 5 to 10. Okay, we're going to need this value later on when the second print2d comes back to the first print2d. Okay, so let's write 10 over here so that we don't forget it out. Alright, now let's start with the execution of second print2d function right from the scratch. Okay, so second print2d function starts and this time the r value is nothing but n3, you can see. So let's write r equals to n3. The space is equal to 10, we are passing 10. So again, first step is r equals to null, no. So first step is not executed, we will proceed forward to step 2. Second statement is space equals to space plus global space. Space value currently is 10, we are adding global space which is 5. So now the new space value becomes 15. Okay. At step 3, again a third print2d function is called and we are passing r of right. Who's there to the right of n3? Because right now r is n3 and when we say r of right we are saying n3 is right. So there is nothing to the right of n3, which means it would have null value. Programmatically speaking it will have null value. So you'll pass null, comma, and you'll pass this space. We just modified space to 15, so we're gonna pass 15. So when this print2d is called, our second print2d will go in a pause state at step 3. Correct? So at step 3 it is going to be in a pause state. It will call third print2d and we are passing null and the value 15. So inside the second print2d the space value has become 15. So let's write 15. Let's not forget that. Let's write 15 over here. Okay. Alright. And now the third print2d execution will begin. So let's start with execution of third print2d. Now talking about the third print2d function, the r value we are passing as null. So r is equal to null this time. The space value is nothing but 15. Correct? Now at the first line itself we are checking r equals to null, then return, and this time r is null. So this statement becomes true and we will execute this first if line, and at this line we are saying return. So we will not execute 2, 3, 4, 5, 6, 7. We will simply come back from third print2d call back to its calling function. Who called third print2d? It was the second print2d. So it'll simply complete its execution and come back because return statement does that. And when this happens, that is when third print2d completes its execution and comes back to second print2d, this second print2d will now resume its operation. Correct? That's how recursion works. I hope you guys know recursion. I have a separate tutorial on recursive function and how recursion works. Do check that out if you want some clarity. So now the second print2d will again resume its operation from step 4 because step 3 is done. Correct? It was paused at step 3. You can see over here. I'm gonna erase this because it will continue its execution from step 4 now. On step 4, for the second print2d, we are saying next line. So this next line instruction is nothing but instructing the cursor onto the command prompt to come on the next line. So by default, we always start from the first line onto the command prompt, but after executing step 4, we will come to the second line. Okay? So why did we do this? This is just for the visual representation of drawing a tree structure. Okay, that is the only motive of this line, and you will understand after we try and few more recursive calls of how this next line impacts the design of the tree. Okay, alright. So step 4 is done. Moving on to step 5. Over here we are calling a for loop. We are saying I equals to global space. What is the value of global space? It is always going to be 5. So from I equal to 5 to I less than space. The space value inside the second print2d is 15. Remember that. So we are traversing from I equals to 5 to I equals to 15. Correct? And inside this for loop, so this for loop is going to run from 5 to 15, which means it will run for 10 times. And inside this for loop in step number 5.1, we are simply printing a blank space. Okay? Again, this for loop is just used to create the user interface to add the spacings. And when this for loop will run for 10 times from 5 to 15, we will add 10 blank spaces. So let's count on the command prompt. We are on the second line. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. So now our command prompt cursor will come onto this block because we've added 10 blank spaces after this statement. Okay. Alright. So now this for loop will complete its execution. Its only purpose was to add these blank spaces. Now let's move forward. And now we are saying print r of value /n. Okay. So at 6th line, we are printing the value inside the r node. R is currently not null. R is currently n3 because we came back from third print2d to second print2d and we are completing the second print2d function. So inside second print2d, you can see we are passing n3. So r of value is nothing but n3's value. And what is the value of n3? You can see the value of n3 is 45. So we will print 45 in this block. We are at this location in the cursor, right? So now we will print 45 over here. And after this, you can see we have a /n, which will now make the cursor go to the new line. So now the cursor will come over here. Okay. Alright, so the first value 45 is printed onto the command prompt and we've done with the step 6. Now we will proceed to the step 7. So when you proceed to step 7, you can see we have another recursive call print2d and we are saying r of left and we are passing space. So we are at the second print2d in the 7th instruction. When we say r of left, we are saying n3 is left. Is there any value to the left of n3? No, it is going to be null. So we are going to pass null over here. What is the value of this space variable? You can see we have made space variable as 15. That's why I made an updated value over here. It was updated at instruction 2 itself. So we are passing 15. So now from this second print2d, we are recursively calling a fourth print2d. And inside that we are passing null and 15. So of course this second print2d will go in a pause state at this 7th instruction. So let's write 7 over here. And now we will begin with the execution of this 4th print2d. Now remember, when you pass null at the very first step itself, you return back. So this 4th print2d will only execute line number 1 if r equals to null because it's going to be true. We are passing null and it's simply going to return back. So let's not waste time. it will simply come back again by doing nothing. When you come back, this second print2d will again resume its operation, and it will resume its operation after step 7. But if you observe the steps in the print2d function, we have nothing after 7th step, which basically means that the second print2d has completed its entire steps of operations. So now it will return back to its calling function, because second print2d, remember, was called by first print2d. So now we can go back to the calling function, which is nothing but the first print2d. So here we go, we come back to the first print2d, and when the second print2d comes back to the first print2d, you can see our first print2d function was paused at step 3. So now it will resume its operation from step 4. So for first print2d, we will resume operation from step 4. Now at step 4 itself, we are saying next line. So we are over here, you can see on the command prompt, we will move to the next line. Okay. After that, we will say for int I equals to global space to I space. So I equals to global space, what is the value of global space? It is 5. So from I equals to 5 to I less than space. Now remember, inside the first print2d, the space variable value is going to be 10. That's why we wrote 10 over here. As I mentioned, we are going to use this now. So I will iterate from 5 to I less than space means I should be less than 10. That is what is the value of space variable. So from 5 to 10, it means that this for loop will run 5 times, and this for loop will print 5 blank spaces. That is what is instruction 5.1. So let's add 5 blank spaces at this position. We are at this horizontal line. So 1, 2, 3, 4 and 5. Okay, so after this execution of the for loop, we will proceed to step 6, and step 6 says print r of value. R is currently n1 because we are in the first print2d call. So n1's value is nothing but the value 30, because n1 has the value of 30. So let's write 30 at this position because our cursor is going to be over here, right? And after that we have slash n, which means that we have to go to the next line. Alright. So far I hope you are understanding this. After this, we proceed to 7th step, and 7th step is nothing but another print2d recursive call, and we are saying r of left. R is currently n1. What is there to the left of n1? We have hash 16. Hash 16 is nothing but the address of n2. So now we are passing n2 over here, and we are also passing the space. The space inside the first print2d is 10. So we are going to pass 10 over here. So a 5th print2d function is called from the first print2d at the 7th instruction. So the first print2d will again go in a pause state at the 7th instruction, and now we will begin with the execution of the 5th print2d function. So I hope you are understanding how the recursion is progressing and also how our output is being drawn onto the command prompt. Let's execute this 5th print2d function from the start. So we are passing n2 and the space value is passed as 10. So first step is r equals to null. No, r is this time equals to n2 and the space value that we've passed is 10. Then at step 2 we are calculating space again. We are saying space is equal to space plus global space. Space value we passed is 10, global space is 5. So now the total becomes 15. So let's update it over here, 15. Then at step 3 we are giving a recursive call to print2d and we are saying r of right. R is nothing but currently n2. You can see what is there to the right of n2. We have hash 26, which is the address of n5. So we are passing n5 comma, and the space value we just modified it to 15. So let's write the space value over here as 15 so that we remember this and not forget. And now we are giving a recursive call. So a 6th recursive call is given from 5th print2d function at step 3. So 5th print2d function will get paused at step 3. And now we will begin with the execution of 6th print2d function. So let's start with the execution of 6th print2d. For the 6th print2d, the r value is nothing but n5 and the space value is 15. So r is equal to n5 and space is nothing but 15. Again, first step, if r equals to null, it is not null, so it will not be executed. Moving on to second step, we have space is equal to space plus global space. So currently the space is 15 plus global space value we've declared as 5. So this total is again going to be stored in the space variable. So space variable gets modified to 20. Let's do that. Let's do 20. At the third step again we are giving a print 2D function call. We are saying r of right. R is nothing but n5. Do we have anything to the right? No, which means we have null. So now we are passing null, and we are also passing the space variable as 20, and we are giving another print 2D call. So 7th print 2D is called from 6th print 2D. We are passing null and 20. Of course, when you pass null, remember that the 7th print 2D will return from the first line itself. So I'm not going to waste time. You've got the hang of it. So we will come back, and 6th print 2D will again resume operation from step 4. At step 4 we are saying next line. So on our command prompt you can see our cursor is over here currently. So we will move to the next line. Then step 5 we are running a for loop. We are saying I equals to global space, which means I equals to 5 to I less than space. What is the space value in the 6th print 2D? Remember it became 20, so let's write 20 over here. So it became 20 at step 2 itself. So we are running this for loop from I equals to 5 to I less than space, which means we are running it to 20. So this time we are going to run this for loop for 15 times, because from 5 to 20 we have 15 numbers. So let's add 15 spaces at this horizontal line. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now our cursor is going to be at this location. Okay, let me mark it at this position. After this for loop is done, that is 5 and 5.1, we will proceed to step 6. We are saying print r of value. R is currently n5. What is the value inside n5? It is 25. So this gets printed at this position, at this cursor location. So let's write 25 over here. So I'm going to write 25 in this block, and after that we have a slash n, which will take the cursor to the new line. So the 6th statement, 6th instruction is done. We will proceed to 7th instruction, which is again a recursive call. We are saying r of left. R is nothing but n5. What is there to the left of n5? We have null. So 8th print 2D is going to be called from the 6th print 2D at this 7th instruction. Of course, when you pass null, this 8th print 2D will return from the first line itself. So you'll come back again, and when you come back you will resume operation after the 7th instruction for the 6th print 2D, and after 7th we don't have any instructions, which means that the 6th print 2D has completed its execution. So now it can go back to its calling function. Who called 6th print 2D? You can see this 5th print 2D had called 6th print 2D. So you come back, and now this 5th print 2D, which was paused at step 3, will execute or will resume its operation from step 4. So we will execute from over here. The step 4 says next line, so you'll go on to the next line. Then you will say for I equals to global space, which means I equals to 5 to I less than space. What is the space value inside the 5th print 2D? You can see it is 15. So from 5 to 15 it is going to execute 10 times. So at this last line we are saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After this we will execute the 6th instruction, which is print r of value. R is nothing but n2 in the 5th print 2D. n2's value is 18. So I'm gonna print 18 over here, because our cursor is at this position now. And after that, at the 7th instruction we're gonna call print 2D, and we're gonna go to the left child. So r of left is nothing but n2's left. Who's there to the left of n2? We have hash 6, which is the address of n4. So we are passing n4, and the space value is going to be 15. So we are also passing 15. So 5th print 2D is going to call 9th print 2D. We are going to pass n4 and 15. And the 5th print 2D, of course, will get paused at the 7th step. Now so far I'm assuming you guys must have got the hang of how the recursion is processing or proceeding. Hence I've already shown the 10th and 11th call. So 9th print 2D is going to call 10th print 2D. It will return back. Then you will print the value 10. Right now I don't have enough space over here, but it would be printed somewhere over here. Then lastly you will have one more call. 9th print 2D will also call 11th print 2D, and 11th print 2D will immediately come back when you are passing null. And then 9th print 2D will complete its execution. You'll go back. Then 5th print 2D will complete its execution and you go back. to first print 2D, and first print 2D will complete its execution because it will resume after step 7 and we don't have anything after step 7, and then our entire recursion and entire execution will stop, and you'll have one more value 10 printed onto the command prompt. Right now I don't have space, but you can take a pencil and paper and try to dry run it. But all in all, you can see that our tree diagram is pretty much covered. So 30 is the root node, then we have 45 and 18. For 18, you have two children, 10 and 25. We printed 25 over here, and 10 will be printed later on somewhere down below. Okay. So on the command prompt also, if you switch to the command prompt, you can see similar to this structure, we have our command prompt output 30, 45, 18, 25 and then 10. This means our pseudocode is perfectly fine, and this pseudocode when converted to a proper C++ code would look something like this. Okay. So this is step 1. I'll put the pseudocode on the top right corner. So this is first step. This is step 2. Then we have step 3 over here. We have step 4. This is step 5. Inside that we have step 5.1. This is step 6. And lastly this is step 7. Okay. So this is nothing but the C++ version, C++ code of the same pseudocode. And I hope you've got the entire working now, and how this print2d function is used to print a graphical view of the entire binary search tree or binary tree. It would work on both binary search tree as well as binary tree. And when you get a graphical view onto the command prompt, it is much more easy to understand which node is a parent or child of which node. Okay. Alright, so I hope you've understood this entire tutorial. You've understood the entire recursion and this print2d function. I'm gonna wrap this video up over here. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends, and I'll see you guys in the next one. Peace.